Well, hi kids, how are you? Thanks for coming. Logarithms can't be much more fun than that. Every time your teacher says the word log, you go like this. Who invented these things anyway? And why are they torturing us with logarithms? And fractions aren't bad enough? You're going to make them complex? Really? Seriously? Complex fractions? I hated fractions to begin with. I've always hated fractions. Fractions are not our friends. Logarithms are not our friends. And yet, Mr. Krause has a smile on his face while he's going to try to teach them to us. I think the guy's crazy. He must be crazy. All right, I'm a little crazy, kids. But you got to get comfortable with these. They're not that bad. Some common rules of logarithms. Let's see if I can slam a couple of the common rules of logarithms on this paper. I don't know if that's going to let me write up here. Log A plus log B is equal to the log of A times B. Log A minus log B is equal to log of A over B. And finally, if I have an exponent or if I have a number out front, 3 times the log of A. Exponents, when you return them, they go back up on top. So this is the log of A cubed. These are and by the way, these are flashcards. Hopefully you have my flashcards downloaded. They're just things you have to know. One other thing, though, is do you all know that x to the 1/2 is equal to the square root of x? Or x to the 1/3 is equal to the cube root of x? I hope you know that. Because if you have 1/3 log of A, you need to remember that this is really equal to log of A to the 1/3, which is really equal to the log of the cube root of A. And they love to ask these questions because it asks a whole bunch of questions in one. Do you know that fractions as exponents really mean roots? Square root, cube root, fourth root, fifth root, 423rd root, whatever it is. It's a root. When you have a fraction as an exponent, it's a root. Your teachers next year are going to expect that you memorize or have this locked in. So, here's where we're going to go. Here's how you condense. Here's the easiest way to condense. First, you return exponents. So we're going to return that. So we need m squared. How many of them have m squared? M squared, no m squared, and no m squared. Now we have addition. Addition, if you remember I just said, is when we condense them, becomes multiplication. So this becomes the log base 5 of m squared times n. Choice 1. I'm going to do them back and forth across. We're going to return the exponent. We're going to return the exponent. Well, then this becomes the log of x squared minus the log of y to the 1/2. But that means the square root of y. Got to remember that. And then I got to remember that subtraction, when I condense, turns to division. Well, the only thing that's under the radical is the y. So it's this is going to turn out to be the log. Oh, by the way, this is not squared, it's cubed. Of x cubed over, so this is the numerator and this is the denominator, but one log, x cubed over square root of y. I don't know why this is down here. I don't know where this came from. This is weird. Just some random thing on the page. I'll have to figure that one out. So we're going to return this. First of all, this is subtraction. So we know we're going to have division. That makes this answer bogus. This thing is in the front. This thing is in the back. So this will be the numerator. This will be the denominator. Don't forget to return the exponent. So it's x squared over y cubed. Done. I'm going to figure out where that thing goes in a second. All right, so this stuff is in after the subtraction, so it will be the denominator. This thing will be the numerator. Now you got to return the exponent. So if I return the 2, I get x squared in the numerator. That's okay. and that's okay. But all of this, the y's and the z's, go in the denominator. Now this is going to be y cubed and regular old z, which is why this is the answer. The z also goes in the denominator. I don't care that these are being added here and you think, oh, that's just multiplying. But remember, you're subtracting off that whole thing, so that whole thing goes in the denominator. So I'm going to return this 1/2. So what I should be looking for is a square root of a. This has a square root of a. This has a square root of a. This does not have a square root of a. And this has a square root of a. Subtraction, when you condense, goes to division. It's b squared. So this is the numerator, and the only thing I should see in the numerator is 1/2 of a to the 1/2 or the square root of a, and the b squared goes in the denominator. Okay, you ready? So this is equal to the log, this is a slightly different problem, of 10 to the x plus 2 over 10 to the x. Because remember, when we subtract, we divide. Now, if you remember correctly, if the bases are the same, we subtract the exponents. So this is the same as log of, if I subtract these, the x's cancel, don't I? X plus 2 minus x, the x's cancel. So I end up with 10 squared, which is really the log of 100. Well, what's my base? My base is 10, even though they don't tell me that. So this one just gives me log base 10 of 100. So I can go 10 to the x equals 100, or x is equal to 2. Now, some of you are going, yeah, whatever, Krause. No way in the world I'm ever going to remember that one. That's actually a pretty tough problem. So let me show you another way to do this one using a little bit of a cheat. We're going to make up a number for x. So we're going to take like 2.3 and we're going to store it into x. Why a weird number? Because I said so. Oh, wait a second. Yeah. Doesn't matter in this case. They're not asking what x is. If they were asking what x is, I'd have to put these numbers in for x. They're not asking. So we're going to do log. I'm not going to put in the base 10. We're going to do it the exact same way they do it, of 10 raised to, that's not squared, excuse me, raised to the 10 raised to the x plus 2 minus log, not going to put that in, of 10 to the x. And it just tells us to. So we can cheat just a little bit. Sometimes that works. Okay, let's go back. We're going to return the 1/3. Now, if you remember correctly, 1/3 as an exponent is a cube root. So this is our numerator. So we're looking for the cube root of m in the numerator. There's our answer. Because this is subtraction, this is going to go in the denominator. Return the 2, becomes n squared. Done. All right, we're going to return this 1/2. It becomes the square root of m. Did I already do this problem? I feel like I've done this problem. Oh, it's really close to 9. So we're going to return the 1/2. So we're looking for the square root of m. That's going to go in the numerator and return the 3 to the n cubed. And there she is. The expression log 8 of 64 is equivalent to, well, I'm going to do this the hard way, and then I'm going to do it then I'm going to do a little bit of a cheat. Log 8 of 64. This is something you can just strictly type right into your calculator. But for those of us who want to really know how to do it, we say, okay, let it equal to x. In order to solve a logarithm, you have to use its inverse function, which is an exponential. And it's all about that base, x. And then these two switch places. 8 to the x is equal to 64. Well, obviously 8 squared is 64. Now, if you don't believe me, you can come over here. You can do log base 8 of 64. And you get 2. Perfect. We're going to return the a. It's going to the 1a. It goes to the a. It's 1/3. So we're looking for the cube root of a. It's got to be one of these two. And then we got to return the b. B cubed. Boom. Ka-ching. All right, so that's it for that simple stuff. We'll come back to some more difficult problems in a minute. So solve for x. Now, these will be like part 2 questions. Now, they're logarithms. In order to solve a logarithm, you have to convert it to an exponential. And it's all about that base, Yeah. So it's 7, and then these two switch to the x is equal to 75. That's kind of difficult. I have no idea how to solve that one. In order to solve that one, you know what I'd have to use? I'd have to use logarithms. I don't know what I was thinking, kids. It said round in the nearest hundreds. You know what they want you to do? They want you to type this thing into your calculator. Log base 7 of 75, round to the nearest hundreds place, 2.22. X equals 2.22. Kind of boring. I'm going to go through these as they are here. The expression, listen, a logarithmic function looks like this. If you grab a log function, it goes to the point 10. It always goes to this point 10, unless you have like +5 or +8 or -2 or whatever. But it will always go through that point 10, and it is always asymptotic to the x-axis, which means you cannot take the log of a negative number. Now, by the way, this is the log of x. It will go to this point. Because I subtracted x, it's going to be doing some weird things. The thing I want you to remember, though, is you cannot take the log of a negative number. So therefore, this thing cannot be negative. Or, in other words, it has to be greater than 0. Which means if x is too big, it will be negative. So we need x to stay small. In fact, if x was 8, it would be 0. So we don't even want x to be 8. We want it to be smaller than 8. And therefore, we want it to be choice 1. Wonder why I skipped around like this. Let me keep going through and doing all these log questions. Okay. So, here's one of those crazy questions. And I'm going to show you 2 different ways to do this problem, by the way. First thing I'm going to do is I'm going to expand this. Now, I have division, and I have multiplication, and I have exponents. So I got lots of stuff going on. So this is the stuff that's in the numerator, and then this is the thing that's in the denominator. So that's the thing that's going to get subtracted. So this is the same as log of x squared plus the log of y, because remember, multiplication reverts to addition, minus the log of the square root of z. Now I want to clean this up a little bit. Exponents go out front, so this is 2 log x plus log y. Now this is really a 1/2 as an exponent. So this is minus 1/2 log z. All right, so my final answer would be 2a plus b minus 1/2 c. That's it. There's my answer. In order to solve a log equation, you must convert it to an exponential equation. So, and it's all about the base. So we're going to take 8 to the 2/3 is equal to, remember these two switch, x plus 1. Now if you put 8 to the 2/3 in your calculator, it will tell you the answer is 4 is equal to x plus 1, and therefore x equals 3. Don't believe me? Okay, come over here, do log of base 8 of, what did we come up with? 3? 3 plus 1. 0.6666666. Is that 2/3? Yeah, it sure is. All right, what are we going to do with this thing? This is a tough question. I'm going to go through and do all the log questions first, and then I'm going to come down and do all the other kinds of questions that are in this problem. Then I'll do the complex fractions, because I know you guys are interested in those really complex fractions. Not the easy fractions, the complex fractions. So the only thing I know about is 2's and 3's. So I got to make 12 up into 2's and 3's. Would you agree this is equal to 4 times 3? I don't know anything about 4's. I know something about 2's. So would you agree this is equal to 2 squared times 3? So what I really want to do is take the log base b of 2 squared times 3. Because the only thing I know about are 2's and 3's, because that's what's given in the problem. So this is equal to log base b of 2 squared, but I'm not going to put the squared here. I'm going to put the squared out front, because exponents go out front, plus the log of 3. Well, I'm almost done. This is 2. This is equal to 0.6931. So 2 times 0.6931 plus 1.0986. So plus 1.0986. So 2 times 0.6931, 0.6931 plus 1.0986, 0986. Enter 2.4848, 2.4848. Done. Problem's over. All right, let's take a look at this next one. So I've got log base b of r squared, going to put the squared out front, plus, because it's multiplication, log of s. All right, this was a simple one. 2 times 0.75 plus 0.25. And if you put that in your calculator, you get 1.75. All right, so let me go through some of these exponential things. All right. I'll go through a couple of these. So anyway, now we have exponentials. In order to solve them, in these particular cases, what you need to do is make sure that the bases are the same. So in this case, this would be 3 to the 4th. Now, if it's odd, your base is going to be 3. If it's even, your base is going to be 2. And the only time that varies is if you have something that looks like it's a 5, that 5 goes into it, and then it'll be a 5. And in most cases, it'll either be a 2 or a 3. So 3 to the 4th is 81, so x plus 2. So 3 to the 4th, that's 81 to the x plus 2, is equal to 27 is 3 cubed to the 5x plus 4. Well, now that the bases are exactly the same, as long as these two things are the same, I've solved the problem. So I'm just going to set those two things equal to each other. Now, in order to save time, I'm going to distribute. So 4x plus 8 is equal to 15x plus 12. Bring this 4x over, I get 11x is equal to negative 4. Sorry, I brought the 4 over, 4x over, I get 11x, bring the negative 12 over. So I get x is equal to negative 4 over 11. Now that to me just seems like I made a mistake. I don't know. I might have. I mean, who knows? It seems like a really stupid answer. So I'm going to try it. I mean, I'm not even lying to you. I really think I made a mistake. So negative 4 divided by 11, I'm going to store this into x. I really don't think this is right. So I'm going to take 81 raised to the x plus 2. X plus 2. Well, hopefully if I did it right, if I raise 27 raised to the 5x plus 4, ridiculous answer, yes. The right answer, also yes. Whew. Man, I thought I made a mistake. That's a weird answer. So, easy way to check it, just plug it in. By the way, kids, I'm not going to lie. Like, 3/4, like maybe a third of this test can be strictly done using your calculator, and there's so many opportunities to check your work. Oh, I missed 16. To come back to that. Ooh. This is a tough question right here. You have to know something. You have to know that if I have 5 to the 0, it equals 1. If I have 10 to the 0 equals 1. If I have a pizza to the 0 power, it equals 1. Anything to the 0 power equals 1. Therefore, what they're really saying to you is 2 raised to the 0 power equals 1. So they're just telling you that 16x squared minus 8x minus 3 has to equal 0. Because in order for it to equal 1, it has to equal, the exponent has to be equal to 0. So I'm going to factor this puppy. So probably 4x and 4x minus 3 and plus 1. I believe that's the factoring. So get x equals negative 1/4 and x equals positive 3/4. I'm going to check those because I'm not really sure about those. So negative 1 divided by 4 stow x. And then I'm going to type in 2 raised to the 16x squared minus 8x minus 3. 1. Ah, good. My other answer was 3/4, so 3 divided by 4 stow x. Enter. I'm not retyping that line. Hopefully this is 1 as well. Yay, 1. I don't know why I don't have too many of these problems in there. I should put more in there. All right, so, okay, here we go. We got a log question. We got division, so that's going to go back to subtraction. We have a radical. So this, remember, is really to the 1/2 power because this is a square root. So this becomes log of a to the 1/2, but exponents come out front, minus log of b cubed, but the exponent comes out front. So it tells you that log a is 2, so this is 1/2 times 2, minus 3 times log b is 3. So this becomes 1 minus 9, which is equal to negative 8. Done. All right, let's get through some. So I think I've finished all these problems, right? Oh. For some reason I didn't do this one. This one, if you just type it in your calculator, right? Or you can do 9 to the x power equals 81, or x equals 2. And I'm telling you, if you type that in your calculator, you're going to get 2 anyway. I think I've done all the problems now. All right. So let's go through a few word problems, then we'll do some complex fractions, and then I'll get rid of you all, because I love seeing you all, but I got things to do. More math, probably. The equation of radioactive decay is defined as that, where P is the part of the substance with a half-life H, remaining radioactive after a period of time T. Whew, sounds complicated. A given substance have a half-life of 6,000 years, so that's H. After T years, 1/5 of the original sample remains. Find T to the nearest 1,000 years. That sounds like a tough problem. P is the amount of substance left after H years. One-fifth the original sample. P is the part of the substance. So I guess P is 1/5. So P equals 0.5 T t to the h. So the only thing I'm looking for is time. So 1/5 is equal to 0.5 t over 6,000. Now, in order to solve an exponential, I have to revert this to a log. So I have to take the log of both sides. I'm going to do the log of 1/5 is equal to the log of 0.5, but that has an exponent, but the exponent comes out front. So t over 6,000. So in order to get this t by itself, the first thing I'm going to do is divide by log 0.5. Don't know what that is, so control division, the log, and just so you know, that's 0.2. 1/5 is 0.2, all over the log. Oh, this should be point. Let me just do it the right way. Control division, because you guys are, it wasn't 0.5, it should be 0.2. I even said 0.2, but I'll do it this way. And this is 0.5. And we get 2.3219. Don't round. God, my eyes all of a sudden got foggy. So I get 2.321928 that should be enough, is equal to t over 6,000. Well, in order to get t by itself, you got to multiply both sides by 6,000. And we're going to round this to the nearest 1,000 years. So t is equal to, so we're going to multiply this times 6,000. 1, 2, 3. 13,931. So 13,931.568. Now be careful. It didn't say thousands place. It said 1,000 years. So t equals 14,000. Okay. The amount of milligrams in a 10 milligram dose of remaining in the body after t hours given by the formula blah. So t is, the starting amount is 10. All right, it's 0.8, so that means it's coming down. So this is decaying or leaving the body. Find the nearest tenth of an hour how long it takes for half of the drug dose to be left in the body. Well, if the formula is A equals 10 times 0.8 to the t, I want to know when it's going to be half as much, so I want to put a 5 here. Isolate the weird thing, I divide by 10, I get 1. I get 1/2, but I'm just going to put it as 0.5. So I get 0.5 equals 0.8 to the t. In order to solve an exponential, you have to use logarithm. So I'm going to take the log of 0.5 is equal to, and we've already said it a million times, exponents come out front, t of log 0.8. Divide by 0.8, log 0.8, divide by log 0.8, and over here I'll do control division, log of 0.8. You do not need to put the 10 in. It'll put the 10 in for you. I think I just did it wrong. 0.5 divided by 0.8. Common mistakes, kids. You don't want to make them. Log 0.5 divided by 0.8. 3.106. So t equals 3.10628. Nearest tenth of an hour, t equals 3.1 hours. Done. Growth of a certain strain of, now that we're doing growth, you'll notice that the base is bigger than 1. If you're going to do a growth problem, this base, and the base is 2.7 in this case, has to be bigger than 1 if it's going to be a growth problem. So the base is 2.7. A is the starting amount. G is the final amount. T is the number of hours. In approximately how many hours will 4 bacteria increase to 2,500 bacteria? We're going to start with 4 and we want it to end with 2,500. So we're going to put 2,500 in for G. In for A is my starting amount is 4. 2.7 raised to the, what is that thing? I forgot my t. So sorry about that. 0.0584 t. On any document you print, that should be fixed, I hope, if I remember. So I'm going to divide by 4. First, you have to isolate the weird thing. You cannot start doing logarithms till you have the weird thing alone. If I divide that by 4, that's at 625. So I get 625 is equal to 2.7 raised to the 0.0584 t. Now I have a base to an exponent. In order to solve it, I have to use logarithm. So log of 625 is equal to the log of 2.7, but that thing needs to go out front. So I didn't leave myself enough room, so let me do that. So 0.0584 log of 2.7. I will divide by log of 2.7. So, oops, I forgot the t. So now, my calculator, do log 625 divided by, it'll fix this for me, because I didn't put it as a fraction. Log, was it 2.7? It was 2.7. 6.4814, so 0.0584 t is equal to 6.48, 14902. I'll divide by 0.0584, and I get t equals divided by 0.0584. Numbers right. And I get 110.9844. 110.9844 to the nearest hour. Round your answer to the nearest hour. Well, t is in hours, so I'm going to round to the nearest hour. Sounds like 111 hours to me. So t equals 111 hours. A little over 4 days, huh? All right, Kristen invests $5,000 in the bank, so that's her initial amount. Bank pays 6% interest. Be careful with this interest rate. You have to convert this to a decimal. We're going to start with this. To double, we want our money to double. So eventually we want to have $10,000. All right, so the principal, R is the interest rate, N is, it's compounded monthly, so N is 12, and T is the length in years. So we want our money to double, so we want to end with $10,000. We started with $5,000, and we got 1 plus the rate, 0.06, that's 6% over 12 to the 12t. First thing I'm going to do is isolate the weird thing by dividing by 5,000. If I divide the left side by 5,000, clearly I get 2. By the way, there's the doubling of the money is equal to, let me put this in my calculator. Let me figure out what this thing is. 1 plus 0.06 divided by 12. It'll make it look like you have it there. 1.005. So 1.005 to the 12t. It's an exponential, so I have to solve it using log. So I'll do log of 2 is equal to, remember this thing goes out front, 12t times the log of 1.005, right? Because we're going to take the log and the exponents come out front. So I want to get t by itself, so I'm going to divide by all of this. 12 times log of 1.05, 005, divide this by 12, pen's going, times log of 1.005. So log 2, this one I'm definitely going to want to do. It's always in your best interest to division. If you can create a fraction, create a fraction. Log of 2 divided by 12 times the log of, I forgot, 1.005. So log 2 divided by 12 times log 1.005. I get 11.5813. So t equals 11.5813. So t equals, rounded to the nearest tenth of a year, 11.6 years. So we're almost done. Is this one E? Oh, good. I wanted E. So this one's compounded continuously. You know you got E when you're compounding continuously. So we're going to start at $10,000. We're going to compound it. I don't know why you need this. You don't really need that. How much money will you have after 2 years? And then it says, determine the nearest dollar, the amount of money he'll have after 2 years. And then it says, determine how much money before he doubles his investment. So we're going to do 2 parts. We got 2 parts to do. One part's easy, one part's a little bit harder. So A equals 10,000 E to the 0.05 times 2. Now, because that's all numbers, I can just type it in. I do not need to use this. They shouldn't have even put that in, and they won't put that in anymore. So 10,000 times E to the 0.05. It was 5%. Times 2. I'll have $11,051. $11,051.71. Now, do you round on this one? Yes, because now I rounded that to the nearest cent, but what did it say? Determine to the nearest dollar. So nearest dollar is A equals 11,052. Now, if they don't tell you what to round to, then you just round to money on money questions. Okay, so how long will it take my initial investment to double? So that if I started at 10,000, I want to end with 20,000. So 20,000 is equal to 10,000 E to the 0.05 T. I'm going to get the weird thing alone by dividing by 10,000. So I get 2, that's the doubling, is equal to E to the 0.05 T. If you're going to solve an exponential function, because the base is E, you need to, and again, if you want to, just look on the top of this calculator. In order to solve an exponential, you need to use natural logs. Not regular logs, you need to use natural logs. So the natural log of 2, not going into y, your teacher should have done that. The exponent comes out front, 0.05 t times the natural log of e. Well, the natural log of e is really just 1, but let's pretend you forgot that. We're going to divide by 0.05 times the natural log of e. And we're going to divide this side by 0.05 times the natural log of e. So in order to solve an exponential, you have to use logs. If it's e that's the base, then you have to use natural logs. So I will come over here, I'll do control division. The natural log of 2 divided by 0.05 times the natural log of e. Now I got to give it e to the 1 because it wants an exponent. 13.8629. So E or T is equal to 13.8629. 8629 to the nearest year. T is going to be approximately 14 years. All right, I'll be back. Just going to save it so I can get my fresh calculator. Complex fraction time. Wait a second, that's not a complex fraction, or is it? A little side note, another lecture, another lesson in exponents. You all, at this point, if your teacher has done a good job, should know that if I have x to the negative 1, that has nothing to do with being negative. That's equal to 1 over x. If I have x to the negative 2, that's 1 over x squared. If I have x to the negative 3, that's 1 over x cubed. Now, having said all that, and I'm going to erase all that, and pause it if you need to, here comes the hard part. If I have 3x to the negative 1, the only thing that has the exponent is this. So this is really equal to 3 times 1 over x, which is really just 3 over x. If I have 5x to the negative 3, this is the only thing that has the exponent. So this becomes 5 over x cubed. And that's a hard part for some kids to realize, because when I look at this problem right here, this thing becomes a fraction, 1 over x minus. Now, the x to the negative 2 is the fraction. That's 1 over x squared, but the 3 stays in the numerator, so it becomes 3 over x squared all over 9 over x squared minus, and I'm going to make this as a fraction, 1 over 1. So the first part of that problem was, hey, you had to make that into a complex fraction. Well, complex fractions are just fractions added on fractions plus other fractions on top of other fractions, like fraction you, man, because I'm not really having a lot of fun with this. All right, guys, you got to get comfortable with it. You got to grow up. You got to be, you just got to get there, man. You just got to. All right, so the first thing I did was I converted these all to fractions. We're going to do a few of these, so hopefully you'll get it. Next thing I want to take a look at is all the denominators. All the denominators. And I want to find the least common denominator, the lowest common denominator. That means the one that I can convert them all to. And in this case, the lowest common denominator is, and hopefully you know how to do this, is x squared. That I can't get into. The x squared is the common denominator. So what I'm going to do is I'm going to multiply everything by x squared. And you'll see why we do this in just a second. This x cancels with one of these x's, and it leaves me just x. This x squared cancels with this x squared, and it leaves me minus 3. This x cancels with this x squared, and it leaves me 9. Nothing cancels here, so I get minus x squared. Well, if you see that, now I don't have complex fractions. I just have a fraction that needs to be simplified. And please, don't start crossing things off. When you have adding and subtracting, it's like they're married. It's like they got a little wedding ring on there. You can't break them up. The only time you can break things up if you have multiplying. Okay? So in the numerator, there's nothing to do. I got x minus 3. In the denominator, I can factor this thing to 3 minus x and 3 plus x. And because the number came first, the number has to come first over here. Well, I'm almost done. These two things actually cancel, but did you notice that one of them is backwards from the other one? In our school, or at least in my classroom, I like to call that the -1 rule. They'll cancel each other, but they make -1. So my final answer is -1 over 3 plus x. Now, the beautiful thing about these is you should never go away knowing that you should always go away knowing that you got this answer right. And I'll show you why how in just a second. Why how, by the way, is New English. I just made that up. We're going to do the why hows. All right, so I'm going to take any number and store it in x. Please, when you do this, don't take some normal number, because if you tried 3, everything would crash. So you don't want to use 3. So let's take 2.8. It doesn't matter what you pick. We're going to unless it's multiple choice and they tell you that these are the answers, you got to try those answers. So we're going to take 2.8 and store it into x. And then I'm going to type this original fraction in, which was x raised to the -1 minus 3 times x raised to the -2 all over 9 times x raised to the -2. 2. Well, I think it was -1, right? -1. All right. And I'm going to get some stupid decimal. There it is. I don't even know what that is. That's crazy. But I'm going to type my regular. I'm going to type the answer I came up with. Control division. Negative 1 over 3 plus x. That's what I came up with. Same weird answer. It's right. We're good. We're done. Ka-chang. Correct. Now, the cool thing about this next problem is it's already made into a complex fraction. You don't have to go through that hard work and make that into a fraction. But I'm going to make these all into fractions. The common denominator, again, is x squared. So I'm going to multiply everything through by an x squared. X squared, x squared, x squared. Everything, x squared. Everything, x squared. Let me use green. This x cancels with one of these x's, and it leaves me 4x. Nothing cancels here, so it's just minus x squared. It's a married couple. Marry them. Put the rings around. Double parentheses. Rock and roll. By the way, I multiplied through by x squared, not just by x. So this is x squared plus 1x cancels here. 5x. These x squareds cancel, minus 36. Oop! All right, so I don't want any comments. This is a married triplet. I guess we got 3 people married here, but it's adding and subtracting, so you cannot cancel. We just got to learn to factor. We're going to factor the numerator. We're going to take out an x, GCF, 4 minus x. By the way, anytime you see a parentheses backwards like this, you know you're going to have the negative 1 rule. It's coming. Be aware of it. All right, let's factor that denominator. X, I believe it's going to be plus 9 and minus 4. All right. We're almost done. This will cancel with this, but makes the negative 1 rule. So my answer is negative x over x plus 9. In order to save time, you're going to have to trust me. That's the right answer. I could go through, stow a number in for x. By the way, I already have a number. All right, you want to see it. You want to see it one more time. I'm going to show you one more time and prove to you that you should never leave these problems until you know you have the right answer. So, I already have some obnoxious number stored into x. So I'm going to do control division. 4 over x, control division, 4 over x. You got to be careful with this. Minus 1, and then get to the denominator, and then 1 plus, I forgot the 1 plus control division, 5 over x, excuse me, I believe it was minus control division, 36 over x squared. Negative, obnoxious. And my answer was negative x over, so control division, negative x over x plus 9. That's what I came up with. Obnoxious. Notice they're exactly the same. Perfect. We're done. Couple more problems. 2 more problems, kids, and we are... Oh, wait. We're on the last problem? Hold on. I don't believe we're on the last problem. Okay, 3 more problems. 3 more problems. And this one is going to be a beast. So let's see what we get here. 1 over m squared. Now, this one's, this is nice. 3 over mn plus 2 over n squared. Remember, the only thing that has a negative exponent is that variable, so it goes in the bottom. Now, this one's tough. This one's going to be m over n squared minus 1 over n. All right, so the first thing I did was I cleaned everything up. Again, this was the only thing being raised to the negative exponent. There's multiplication. Excuse me. There's multiplication there. So my lowest common denominator, here's why it's going to be hard. My lowest common denominator is m squared n squared. Whew. So I have to put an m squared n squared, m squared n squared, m squared n squared, m squared n squared, m squared n squared. Yes, time consuming. Don't be lazy. M squareds cancel. I'm left with n squared. 1m, 1m. 1n, 1n, minus 3mn. N squareds cancel, plus 2n squared. Notice I already married them up, so you don't do anything stupid. Estupido. The n squareds cancel. I'm left with m cubed. 1n cancels, minus m squared n. I'm going to marry them up so you don't do anything stupid. Now, it's not a complex fraction anymore. It's just a fraction, which we don't like anyway. So I'm going to factor the denominator by taking out an m squared, and I'm left with m minus n. Now I'm going to factor the numerator, which is going to get a little bit tricky. So let me go to red. I'm going to stay with black. So it's n and n. Multiply to 2, positive 2, and add up to negative 3. Well, that's easy. Minus 1. This should be m's. These should be m's. Minus 1m minus 2m. So these multiply to positive 2m squared, and it's negative 2mn, and negative 1mn makes negative 3mn. So I don't necessarily need this 1 here. That might be a little bit sense of confusion. So now I can start canceling stuff. This n minus m cancels with this m minus n, but it's backwards, so it's the negative 1 rule. So my final answer is negative n minus 2m all over m squared. And no, you don't have to distribute that negative. All right, 2 questions left. And that was the hardest one. That's the hardest one. If you did that one right, whoo, you are a genius. We're going to convert this into a complex fraction. So 1 over 1 plus 2 over x, 1 over 1 minus 3 over x minus 10 over x squared. The common denominator is x squared, so I'm going to multiply everything through by x squared. Not going to be lazy. Nothing cancels on the first one. We're going to marry these puppies up. X squared plus 2x. X squared minus 1x cancels with one of these. 3x minus 10. Almost done. Now we just have to factor. They're married. Don't do it. X plus 2. I'm pretty certain I'm going to have an x plus 2 in the denominator. Otherwise, it would be kind of a boring question. And I am. X minus 5 here. Because negative 5 times 2 is negative 10. And when I add those up, I get negative 3. I cross off the x plus 2's. And I'm left with x over x minus 5. Last problem. So, 1 over x minus 5 over x squared all over 3 minus 13 over x. This looks like it's going to get crazy. There was an x here. Minus 10 over x squared. I'm going to multiply everything through by x squared because that's the common denominator. So I get, let's see, 1 cancels with 1, leaves me x. We're going to marry them up. X minus 5, because these cancel. This is going to give me 3x squared. Let's marry them up. 1x cancels with 1x, so it's minus 13x minus 10. Well, I'm going to be pretty guaranteed that the numerator is x minus 5. The denominator is going to be 3x and x. So I'm going to guess this is going to be x minus 5. If that's true, this has to be x plus 2. Let's see if that works out. Lost my pen. This is negative 15 plus 2 is negative 13. So that, in fact, works out. Start lopping stuff off. This x minus 5 cancels exactly with that x minus 5. So this is all I have left over, but it's in the denominator. So don't forget you still have a 1 up here. So my answer is 1 over 3x plus 2. All right, guys. I hope you got a lot out of that. I hope you enjoyed it. I hope you learned something. Hit the subscribe button. Get 100 on that Regents. Email me. Good luck, kids. Good luck. Keep working hard. It's almost over.